In this lesson, we're going to look at geometric series. This is titled Module 2 because it's the second lesson in geometric series. Geometric series is related to a geometric sequence, but instead it is the sum of the terms of a geometric sequence. So if a geometric sequence is listed as 1, 2, 4, 8, 16, and 32, the related geometric series would be 1 plus 2 plus 4 plus 8 plus 16 plus 32. So for the geometric series above, the sum of the first 6 terms is 63 because when you add up the first 6 terms, you get 63. There's two formulas having to do with the general sum of a geometric series. One formula is here, the other formula is here. Where they differ is important because it helps you utilize or figure out which formula might be more useful. In the first formula, it has the number of terms. In the second formula, it has the value of the last term in what you're trying to find. So we're going to look at two problems in this particular case. If you ever want to reverse and pause to look at the formula more closely, you could. I have them listed here again. The first question says the sum of 2 minus 4 plus 8 minus etc. 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 plus tn is negative 2,730. How many terms are in the series? One method you could do this is just add up and follow the pattern until you get to negative 2,730. So if I did 2 minus 4 plus 8 minus 16 plus 32 minus 64 plus 128 minus 256, because the common ratio is 2. At some point, we would get to negative 2,730, and we could figure out how many terms it took to get us there. That's one method. Another method is to use a formula. In this particular case, because we're trying to find out how many terms there are in the series, the more useful formula here would be the first one, because n represents the number of terms in the series. The second one represents the value of the last term. So this one is less useful. Now if we look at the first one, here's what we'll do. We know that the sum of the series is negative 2,730, and that's equivalent to the first term, which is 2, times the common ratio, which I've mentioned is negative 2 to the power of n minus 1. And that's all over the ratio minus 1, so negative 2 minus 1. So if we start simplifying this and starting to solve for the exponent n, we'd have negative 2,730 is equivalent to, and if I expand this in, what I'm going to have is equivalent to 2 times negative 2 to the power of n minus 2, and that's all over negative 3. If I multiply both sides by negative 3, I'll get rid of this. So at this point in time, we have 8,190 is equivalent to 2 times negative 2 to the n minus 2. So in order to start solving, I would add 2. I have 8,192, is equivalent to 2 times negative 2 to the power of n. And if I divide by the coefficient 2, I can start seeing where I can get more closely. So in this particular case, 8,192 divided by 2 is 4,096. So we have 4,096 is equivalent to negative 2 to the power of n. Now, in order to solve for an exponent, what I'm going to propose that we do is actually just guess and check. So I'm going to guess and check to see how many terms we think there are. And so if I do negative 2 to some exponent, I need to get 4,096. So let's just try it out. Let's do negative 2 to the power of 10, for example. That's 1,024. So it's going to be probably a few more exponents more than that. So if I do negative 2 to the power of 12, I get 4,096. So we know that n equals 12 because negative 2 to the power of 12 equals 4,096. So our answer would be 12. There's 12 terms. Let's look at one more example. The second term of a geometric series is 2 over 27, and the sixth term is 6. Determine the sum of the first 7 terms. So let's look at what that might look like. So we've got a list of 1, 2, 3, 4, 5, 6, 7. We know that the second term, which is term 2, is equivalent to 2/27, and we also know that the sixth term, which is term 6 here, is equivalent to 6. And the question is, when I add all these up, what's the sum? In this particular case, we know the number of terms are going to be. We could also actually find out shortly what the value of the last term is, but something that we definitely need to find out because we have too many unknowns. We don't know the first term, we don't know the last term, we don't know the common ratio, we don't know a lot of things, is to first of all maybe investigate what the ratio is, because if we know what the pattern is, we can determine what all of the terms are. So in order to do that, what I would look at is the fact that to go from the second term to the sixth term, you have 4 common ratios. So if you'd like to use the pattern from geometric sequences, what that would say is that 2/27 times r to the 4th is equivalent to 6. So now we can actually solve. If I divide by 2/27, r to the 4th is equivalent to 6 divided by 2/27. That's equivalent to 81. So now if I take the 4th root of 81, I should get the common ratio. So the 4th root of 81 would be 3. So it looks like the common ratio in this particular case is going to be 3. So what I could do is work my way backwards or forwards from there to figure out the pattern. So for example, 2/27 times 3, it would be 6/27, or in other words, if I wanted to reduce that, it would be 2/9. Times 3 would be 2/3. If I times that by 3, I would get 2 times 3 is 18. And to go in the reverse order, what I would do is divide by the common ratio. So if I divide by 3, what I would get in this particular case would be 2/81. If you need to see that, I can show you. 2/27 divided by 3 is the same as 2/27 times the reciprocal, which would be 2/81. So in this particular case, we actually could just add this up if we would like to, or we could use either one of these formulas. In this particular case, again, it doesn't matter. Now we know the number of terms, we know the last term, we know everything that we need to know. Maybe I'll just use the second formula if you'd like to, but it doesn't matter. The sum of 7 terms is equivalent to the ratio, which now we know is 3, times the last term, which is 18, minus the first term, which is 2/81, all over, in this particular case, it's the ratio minus 1, so 3 minus 1. So the sum of 7 terms is equivalent to 54 minus 2/81 all over 2. And I'm just going to calculate this and find out what the sum is. You could also do this in fraction form, or in other words, in exact value form if you'd like to. So 54 minus 2/81 equals, and divide that by 2, and I get 26.987, etc., etc., etc. If you'd like to do this in exact fraction form, maybe I'll show you right now. Other than that, we're done the lesson. So for those who need fraction practice, here's how we would do that. S/7 is equivalent to, in 54, in order to add or subtract fractions, you need to have a common denominator. So 54 times 81 would give us 4374/81. So 4374 over 81 minus 2/81 all over 2. So this would become 4372/81 divided by 2. So 43, and dividing is the same as multiplying by the reciprocal. So this would be the same as 4372/81 divided by 2, which is the same as timesing by 1/2. So it would be equivalent to 4372 over 162, and I could put that in reduced form if I'd like to. So I could divide those by 2. 4372 divided by 2, 2186/81. And that might be the most reduced form. Now what you'll see is if I do divide that, 2186/81, I'll also get the same answer, 26.987, that I already had previously.